This is Math 6, Lesson 4-7, Least Common Multiple. A multiple is the product of a number and a non-zero whole number. Like a multiple of 6 is 12 because 6 times 2 is 12. A common multiple is a number that is a multiple of each of two or more numbers. The least common multiple is the least or smallest multiple that is common to all of the numbers. Today we're going to focus on least common multiple. You can find a least common multiple by using a list of multiples. You are simply going to list the non-zero multiples and then identify the lowest or least common multiple from the list of common multiples. This works well when your numbers are small. It doesn't really work well when your numbers are very large because it can get very tedious, very difficult, and if you make a small mathematical error, you're never going to find the least common multiple. Let's take a look at this first one, 10 and 12. My multiples of 10 are 10 times 1 is 10, 10 times 2 is 20, 10 times 3 is 30, 10 times 4 is 40, 10 times 5 is 50, 10 times 6 is 60. I'm going to stop there for a moment. 12. 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48, 12 times 5 is 60. There I go. I have found a least common multiple. Because up until this point, we did not have any numbers that were in common. But now I look and I see, aha, 60 is a multiple of both of those numbers. So the least common multiple then must be 60. I didn't have to go too terribly far for this problem, which was good because 12 times past 5 is getting fairly large and it gets harder and harder for people to multiply. Let's take a look at the next problem. All the multiples of 7. Okay, 7 times 1 is 7. I didn't do that very well. I don't need a comma in there. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 28. 21, not 28. See, if you mess up somewhere along the line, it will mess up the entire thing. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. 6 times 7 is 42. 7 times 7 is 49. 8 times 7 is 56. 9 times 7 is 63. I'm looking at it going, there's nothing that's a multiple of 10 yet. 10 times 7 is 70. Oh, thank goodness, because I think I just finally met one. Okay, multiples of 10 are 10, 20, 30, 40, 50, 60, and 70. Oh, look, we finally found a common multiple. 70 is our common multiple. Look how far I had to multiply out 7 to before I found my least common multiple of 70. Alright. Let's look at the next one. 6 and 9. Okay, multiples of 6 are 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. Multiples of 9. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. Now I went beyond what I needed to because I wanted to show you sometimes you don't pay attention. And I actually have two multiples here. I have 36 and I have 18. But which one is the least common multiple? The smallest common multiple is 18. So my least common multiple is going to be 18. Now here's a big problem that some students have when they work with least common multiple. They hear the word least and think our numbers should be small. Your least common multiple is just that. It's a multiple. You have to multiply. So it's going to be larger than the numbers you're working with. It's going to be either the same or larger than the two numbers that you're working with. If we looked at our first common multiple, 60 was much larger than 10 and 12. Second one here, 7 is much larger than, or 70 is much larger than 7 and 10. And our last one, our least common multiple of 18, is larger than 6 and 9. The least common multiple will be either the same or larger than your multiples that you have. It won't be smaller than the numbers that you're given. The best it could be is exactly the same number. That's one way for finding least common multiple. Not my favorite way. Works well when your numbers are small. Does not work well when your numbers are bigger. When your numbers are bigger, it's much easier to find the least common multiple using prime factorization. You will write the prime factorization of each number. you will identify all the common prime factors and then find the product of the prime factors using each common prime factor once and any remaining factors. There's the key there with using prime factorization. Let's take a look at this. And you could use either the division ladder to find prime factorization, or you can use a factor tree, whichever one you're more familiar with or comfortable with. Okay? If I'm going to use if I have 6, 9, and 15, if I decided I wanted to use a division ladder. If I want to use a division ladder here for 6, 9, and 15, I need to find a number that divides evenly into 6, 9, and 15 that is prime. Okay? I know 3 will go into all of those. 3 goes into 6 twice, 3 goes into 9 3 times, and 3 goes into 15 5 times. Guess what? All of those numbers are prime, every single one of them. Since I've got it broken down to all prime factors, I can just circle all my prime factors here, and my least common multiple then is going to be the multiplication of all of those prime factors. 3 times 2 times 3 times 5. Okay, let's see. 2 times 5 is 10, 3 times 3 is 9, so my least common multiple is 90, okay, which is much larger than 6, 9, and 15. Okay. Let's take 6, 8, and 12. Now again, I could use a division ladder, or I'm going to use prime factorization just to show you. I might go back and do both of these with the other form just to prove that it works. So if I use 6, 8, and 12, so let's do 6, let's do 8, let's do 12. 6 is 2 times 3. 8 is 2 times 4. 2 is prime, but 4 is not. 4 breaks down to 2 times 2. 12 is 2 times 6. 2 is prime. 6 is 2 times 3. So 2 and 3 are prime. Once you have them broken down into prime factorization using a factor tree, you need to list the factors. 2 times 3 are the factors of 6. 8, the factors are 2 times 2 times 2. And 12, the factors are 2 times 2 times 3. Okay? So once you've had those, you identify all the common prime factors. Okay, so they all have a 2 in common. Okay, 2 of them have a second 2 in common. 2 of them have a second 3 in common. Okay, with greatest common factor, they have to have everything in common. With least common multiple, they don't all have to have it in common, because what you're doing is whatever you circle, you're multiplying together once. We have this extra 2 at the end. So the least common multiple for 6, 8, and 12 is 2 times 2 times that extra 2 that was hanging out over there times 3. What did we circle? We circled one group of 2's, a second group of 2's, and then a lone 2, which makes our 2 times 2 times 2, and then a group of 3's. So our least common multiple here then is 8 times 3, which is 24. This can be a really difficult concept for some people to pick up on. So let's just do this one again. I'm going to use the division ladder this time. So let's take the numbers 6, 8, and 12, and let's use the division ladder. Okay? What goes into 6, 8, and 12 that is prime? I know 2 does. 2 goes into 6 3 times, 2 goes into 8 4 times, 2 goes into 12 6 times. Now you might look at this and go, ooh, okay. Nothing goes into both 3, 4, and 6. So I might look at this and go, oh, this is kind of interesting. How do I do the division ladder from here? Well, then I look at it and go, okay, the 6 is done, but the 8 and 12 is not done, because I still have a 4 and a 6 left, so I'm going to bring the 4 and I'm going to bring the 6 down. So 4 and 6. Okay? 2 goes into 4 twice, 2 goes into 6 3 times. So now I have this 2 and this 3 that I started with. And then I had to finish my division ladder. Here I have another 2, and a 3. So I have 3 2's and 3 3's, but these 2 3's they have in common, because I have a 6 here and a 6 here. This is where this can get really, really confusing. That's why I don't tend to like to use the division ladder with least common multiples, because if it doesn't come out really nice, it's very difficult to understand. So sometimes that can be confusing, because I already have this 3 from this 6 here. I don't need to use this 3 again. Since I had this 3 up here, I don't need to, since I had it here, I don't need to use it here, because this number here matches with this number there. And you're like, wow, that's weird. It is kind of weird. Okay. So the greatest least common multiple would be 2 times 2 times 2 times 3, which is still 24. We'll talk more about using the division ladder in class, so hopefully it'll be a little bit make more sense when we do lots and lots of examples in class.